Okay, so this is just a run through of the assessment practice problem. So the common assessment is something we give to all the 13, 14 classes. Other classes also have common assessments. So every class that's a 13, 14 class is supposed to take this assessment at some point. This is your practice problem. As you'll see, there is another assignment that I set up that is just the common assessment. That is the one that you're graded on. So this one is just for practice. So if you see bobcats, that's the practice problem. So the bobcat population in the Everglades region of Florida has been declining over the past 20 years, largely due to the establishment of the Burmese python as a self-sustaining breeding population. Suppose that the bobcat population in the Everglades region was 120 in 1985. In 2005, the bobcat population was 20. Let the variable t represent years since 1985. All right, so the first thing we want to establish is we want to identify what is the independent and dependent variable. So if you remember, the independent variable is essentially the input. So it's what we have to input to get an output. So we're thinking about this as we want to try to establish a kind of a function here. So you need something to input and then something to come out. So what we can input that we know is going to be a function is if I input time, it should output population. So my independent variable would be time in years since 1985. The dependent is going to be the bobcat population, so the number of bobcats. This is going to be our t, and we'll just call this one y for us, because usually x and y, we'll have it t and y because we have time. All right, so next part is we want to form a table to represent the population of bobcats in terms of years since 1985 and calculate the average rate of change or slope of the bobcat population over time. All right, so when we set up a chart, remember that we always put independent variable first and then dependent variable second. Okay, so remember T, our independent variables, years since 1985. Y was supposed to be our bobcat population or number of bobcats. So since this is years since 1985, I'm gonna make my little chart here of my T's and my Y's. If this is 1985, it's been 0 years since 1985, so that is year 0. And at year 0, what we had saw was that the population was 120. So let me just scroll up a bit, so you can see that. So 1985, 120 bobcats. That means this time here, this is 2005. So how many years is this since 1985? Well, that's 20 years. So here T is 20. And 20 years after 1985, the population itself is down to 20. Okay, so we got our numbers here. We got our chart. So next we want to find our average rate of change. Then make sure we round it to 1 decimal place if necessary. We may need round, we may not, and include units in your answer. So my slope, that's going to be m. To point this out here, we don't have x and y's here, we have t and y's. So this would be our t1, y1, and this would be my t2, y2. Let me fix my 2 here, or my 1. Well, like I said, these are just the same thing as your axis. So what your formula is going to look like here is you put your y's on top still, y2 minus y1, and instead of x's, you just have t2 minus t1. So we see there is that we have The year 20 is Y1, or 20 years is Y1. And then, or Bobcats, sorry. And then Y1 is the 120 Bobcats. 20 and 20 is a little confusing. T2 is going to be 20 years after 1985, and then T1 is 1985, so it's just 0. So if you do that difference, that's a negative 100 over 20. So remember, this is Bobcats, and this is years. So if we simplify that, we're going to get a negative 5 Bobcats each year. So our next part here, in a complete sentence, describe the meaning of the average rate of change in the context of the situation. So there's a lot of ways to say that, but essentially the idea is that we see we have a negative 5 Bobcats per year. So we are losing 5 Bobcats a year. And we're losing 5 Bobcats a year after 1985. So after 1985, the Bobcat population, you can say the Bobcat population, the Everglades too if you want to, but the Bobcat population has fallen by 5 Bobcats each year. So some variety of that would be perfectly fine. So it could be the Bobcat population is declining by 5 Bobcats every year after 1985. But it's important to state that we know this is happening after 1985, and we're losing 5 Bobcats each year. So as long as your sentence is capturing those two points, then you're good. So we have one last question. So let me restructure everything and we'll do question 4. Okay, number 4 is going to use the data that we had before. So some of the work we've already done. So we're going to use the table and your slope and write a linear function, which we're going to call FT, that gives the Bobcat population in terms T of years since 1985. Use your function to estimate what the Bobcat population in the Everglades region in the year 1990 would be. And you once again want to include units in your answer. Okay, so there's 2 ways you can go about this. You can use y equals mx plus b, or you can use y, oops, sorry. Let me fix that, because we don't have x, we have t. So it would be what we usually call as y mx plus b. But we're just going to make that little change there, y equals m e plus b. And then we have this one, y equals y1, or y minus y1 equals m x minus x1, which we can change to y minus y1, because we don't have x's, we have t's, so that would be t minus t1. So we want to make sure you have that t in there because we have it here. Okay, so we already know what m is. M is minus 5. So in this case here, for the y equals mt plus b, we just need to figure out what this b would be. So if you remember, this is a point that's called 0b. That's where your input is 0 and the output is going to be the b. So we see we have that point right here. So this is really just the point 0, 120. That means b is just 120. So I can rewrite this as y equals minus 5t plus 120. So we wanted a function that is f of t. So instead of writing y, we just say, oh, f of t is going to be negative 5t plus 120. Okay. The other way to do it is using this formula, which means I just need to pick a pair of points. So it could be this pair or it could be this pair. But once again, we know that slope is going to be that negative 5. So let's say, just for fun, we'll pick these pair of points. So we're going to have y minus, my y here is 20, gonna be equal to -5 times t, and the point that goes with that is that 20 minus 20. So we'll have y minus 20 is equal to -5t minus 5 times minus 20 is going to be plus 100. If I add my 120 to both sides, I'm going to get y is equal to -5t plus 120 again. Or like we said, f of t is equal to -5t plus 120. Either way, you should end up with that is going to be your answer. So we have this one last bit to answer, which is we want to know what is the population in 1990. Okay, so we want to figure out what the population is in 1990, 1990. So remember, our T's are years since 1995. So the T here is just how many years is this after 1995? I probably don't need to do this part to see that is 5 years later. So what I'm looking for is f of 5. So it'll be -5 times 5 plus 120, which is going to be -25 plus 120, which is going to be 95. And it's 95 what? Well, this is a function that gives me the bobcat population after I find t. So this would be 95 bobcats. There's 95 bobcats in 1990.